So for problem 11.52 in Mastering Physics, we have a 1,500 kilogram weather rocket accelerates upward at 10 meters per second squared. It explodes 2 seconds after liftoff and breaks into two fragments, one twice as massive as the other. Photos reveal that the lighter fragment traveled straight up and reached a maximum height of 530 meters. What was the speed of the heavier fragment just after the explosion? So first let's draw a picture. And so we have, let's set the origin at y equals 0, and we have a rocket traveling upwards with an acceleration of 10 meters per second squared, and it explodes after 2 seconds. So at 2 seconds it explodes into two fragments, and the lighter fragment travels straight up. So let's do this, and this will be the lighter fragment. Lighter fragments, and the heavier fragment, we'll just do that, and let's make it bigger. Heavier fragment, and also tells us that the lighter fragment reaches a maximum height of 530 meters. So we know that the distance from here to here will be 530. So we can just say that's 530 meters. And that's pretty much what they are. They also have given us that the lighter fragment is, the fragments, one is twice as heavy as the other. So with some algebra we can say that 2x plus x equals 1500. Take out the x, we have x 2 plus 1 equals 1500. So 3x equals 1500. X equals 500. So for masses of the rockets and the fragments, we can say that the mass of the rockets is 1500. The mass of the lighter fragment is 500 kilograms. And the heavier fragment has a mass of 1,000 kilograms. So these are values we will need to later use. And the first thing we can do is write down the equations we'll need. One of them is the momentum one, so we know that the total momentum of the rocket will have to equal the momentum of the lighter fragment plus the momentum of the heavier fragment. So using this, we know that m times v of the rocket will have to equal m times v of the lighter fragment plus times v of the heavier fragment. And our goal now would be to find the velocities of these. We know that the rocket has an acceleration of 10 meters per second, so we can say that we can use Vf equals at plus Vo. Initial velocity will be 0 because it's starting from there, so we end up with Vf equals, they give us 10 meters per second in 2 seconds. So final velocity of the rocket will be equal to 20 meters per second. So for here we can say it's 1,500 kilograms at 20 meters per second. The mass of the lighter fragment we already established was 500 kilograms. And the mass of the heavier fragment was 1,000 kilograms. Now all that's left is to find the velocity of the lighter fragment and the velocity of the heavier fragment. In order to do that, we would need to use the equation x. So to find the velocity of the lighter fragment, we first need to find the distance from here. We need to find this distance from here to here, and then we could subtract this from that, and we could find this distance. Then we can use an equation to find the velocity. So to find this distance, we would use x final equals x initial plus velocity initial times time plus 1/2 at squared. Both of these are 0. We end up with 1/2 10 meters per second at 2 seconds squared. That equals 20 meters. So the rocket travels 20 meters before blowing up, and that would mean the distance from the explosion to the max height of the lighter fragment would be equal to 510, because 530 minus 20 equals 510. So now that we have the distance from the explosion to the lighter fragment, we can use the equation final velocity squared equals initial velocity squared plus 2ax, and the final velocity will be 0 because it reaches its maximum height, and for that split second it won't be moving. The initial velocity would be our unknown, or what we're trying to find, plus 2 because it's not, the rocket's not accelerating anymore, it's actually decelerating with gravity, so it would be negative 9.8. And the change in distance we just found, which is 510 meters, so we can put 510 there. That would be 0 equals v plus v minus 9,996. That'd be squared actually. So that would be 9,996 equals velocity initial squared. So take the square root, we end up with velocity initial equaling 99.97 meters per second. So that would mean the velocity of the lighter fragment is equal to 99.97 meters per second. Now that we have all these values, our only unknown is the velocity of the heavier fragment, and this would tell us the velocity right after the explosion, which is what the question is looking for. So now if we combine all these and then solve for v, we end up with 30,000 equals 30,000 equals 49,985 plus 1,000 v, and this is what we're solving for here. So if we subtract, we end up with 30,000 minus 49,985 equals negative 19,985 equals 1,000 v divided by 1,000. We end up with v equaling negative 19.985.
Very good.
So we end up with a negative answer, but because it's asking for speed, you can't exactly have a negative speed, so this would just become positive 19.985, and we were given 2 sig digs, so the final answer would be 20 meters per second. Yep.